and welcome to SimFest 2020, and to this talk, Relational Interactions in Game Design. This is a talk for you if you are a game design theory nerd or is someone that is looking for better conceptual tools to design your game. Who am I? My name is Simon Hoffiz. I am an architect by day, a game maker by night, that also likes to compose music for games. I hold a bachelor's degree in environmental design, a master's in architectural design. Down there below you can see some of my school projects in which I had the opportunity to do a master thesis. This project gave me the opportunity to research and use the two concepts that we're going to use as a fundament to develop our talk, affordances and signifiers. I have 6+ years in the architectural hospitality industry. So for my game making experience, I have helped and collaborated in 13+ games in which I have done general design, I have done level design, music, programming, and asset creation. Currently, I am leading a project called Gala Strike. So this is it for me, my introduction. So now let's get into the talk. And for that, we need to first introduce affordances and signifiers. Let's start with the concept of affordance, which was first introduced and brought forward by this gentleman called James J. Gibson for the psychology field in his book The Ecological Approach to Visual Perception, in which the concept of an affordance is that every single possible action that a person can do with the object or in the environment. Let's bring some examples in. So let's say that you see a person entering a room with a chair on one hand and a basketball in the other one. What is the first thing you expect that person to do with it? Well, I'm pretty sure you would say that person will sit on the chair and will throw the basketball. But the concept of affordance tells you that in reality you can also do other things with it. Like you can throw the chair and you can sit on the basketball, because these are things physically capable of a human doing with the object. Now, this concept of affordance was further developed by this gentleman called Don Norman for the design field in general, in his book The Design of Everyday Things, and is stating that an affordance is not only the possibilities of what a human, a person, a user can do with an object, but also that the form of that object has to guide how the user is going to use the object. Therefore, the form has to imply its function. So let's go back to our example of the chair and the basketball. So now you see a person with a chair. This type of affordance tells you that the person will sit on the chair. It helps you expect what is going to happen with the object. When you see someone with a basketball, you expect that they will throw it. Now, this is not only a concept of the affordance, but Don Norman also brought the concept of a signifier, which is the characteristics of that specific object, of that form, that is guiding that person how correctly interact with the object, how the designer intended it to be used. For example, we have a door system. The door affords the manipulation of the knob, the disengagement of the locking system, the panel rotation on the axis, in this case the hinges, and passage through it. Let's look at an example of this, one that I'm sure everybody has encountered. Double storefront door with vertical handles. Doesn't matter how many times we have interacted with this particular type of door, there's like an 80% chance that every time you're going to go and open it, you miss. You are trying to open it in the wrong direction. And why is this? I mean, we all feel silly about this because we're expecting that we should be able to know how to operate something as simple as a door, right? Well, this is not your fault. This is badly designed signifiers. And yes, you're welcome. Now you have an excuse to tell yourself. So let's look at another example of a door. This door has no design features. It has no other signifiers to tell you how to operate it. The only things that you are able to see are the seams separating it from the wall. But if you sit down and you try to figure out, just by looking at it, how this door operates, there is no way for you to know that this door operates rotating on a central axis. There are no signifiers, there are no landmarks, no guiding points to tell you how to operate this door. And this is why the design features, in this case the knobs and the handles, guide the user into how correctly operate a door. For example, if we take ergonomics and psychology and we bring them in here, we know that whenever we encounter a horizontal bar in a door, we tend to lean towards wanting to push it. But when we encounter a vertical handle, we lean towards pulling it. And this phenomenon has been so impactful and fundamental in the design field that it has been coined as the Norman door, just to capture this concept of affordances and signifiers. I also want to make a point that we interact with affordances and signifiers every day of our lives, almost in every instance. If you are working, touching, manipulating something that is man-made, it had to go through a design process. For example, a mug, which tells you specifically where to grab it whenever it has hot liquid in it. A mouse, which doesn't afford you to easily pick it up at the table, but it does let you put your hand comfortably on it to be able to move across an horizontal surface. And of course a game controller, which is basically screaming at you on how to grab it and where to put your fingers to operate the buttons correctly. Now, until this point, we have been talking about affordances and signifiers in the physical space. I want to move this conversation to the digital space. And that's why I'm taking the ubiquitous hyperlink and explore it in the eyes of affordances and signifiers. So this hyperlink affords being clicked, and it also affords an added layer of information, be it in a new tab or in a bubble of information. And the signifiers are the underlined text, the different color it has from the rest of the text around it, and the cursor change when it is hovering over it. Now these are the fundamental aspects that are used to design our modern UI interfaces. But I want to take a further step into the digital space and focus on the game space. For example, we have in-game components like main menu screens, which look more like UI, but we also have non-avatar games. And what I mean by that is games that your input directly affects the game. It doesn't need an avatar to interact and be a liaison on that digital world for you. And these games, these non-avatar games and main menu and the UI screens in the game, even though they're in the game or they are games, they are more akin to our modern UI designs. But it is not the same case when we are traversing and navigating and living in a world with an avatar, a game world with an avatar. So what I find interesting in this is that this specific game space has a combination of the digital space and the physical space aspect mixed together. For example, let's quickly talk and take as an example the masterful first level of Mario. And even though we can talk a lot of things about its design, let's just focus on one element, the block with a question mark, which affords the player to hit it to get a reward, and it is signifying that the block is interactive to the player because it's using a question mark that is guiding the player. The same thing happens with modern games, like the latest God of War game, with diegetic and undiegetic components. For example, the UI component in the chest that is specifically telling the player you can interact specifically with this chest. Or in the environment where runes in this game tell and guide the player to a specific path. In this case, in this example, to a specific section of the wall that can be climbed by the avatar. And in the Assassin's Creed games, a very interesting parallel is happening between the physical world and the digital world, where the game designers are expecting you to be able to navigate the digital world on the basis and your knowledge on how you would interact and navigate the physical world. For example, in the physical world, if you go to a wall and you see a ledge, you know that if you can jump, you can grab onto it and maybe climb it. That's the same thing happens in the world. There are almost no UI elements in it telling you you can climb this wall, but you're using your physical world knowledge to be able to navigate the digital world. So now that we know that affordances and signifiers are necessary for our everyday interactions, we also need to understand that they also require an amount of working memory to perform the task, and this is also known as cognitive load or cognition. So let's use our storefront door example to explore the cognition load concept. So it requires fairly little cognition on our part to be able to operate a door. It's supposed to be a simple task of opening them so we can pass through them. And as everyone knows, when you're opening a door that is working how you expect, you almost notice nothing of it. It's almost as a background task. But what happens when the door doesn't work like you expected? Well, now you need to figure out why that is, and therefore you need to allocate more cognition to that task, or increasing the amount of cognitive load that you're using just to open the door because of bad signifiers. So how can we apply this to game design? Well, every user has a goal, be it making toast, picking up and interacting with a phone, or navigating a game world. So every goal necessitates an interface with an object or the environment. And this in turn is going to require cognition from the user to be able to operate successfully. So what we're doing is we're calling this interface point a relational joint. And the line between the user and the goal we're calling a relational pathway. So let's apply these concepts to making toast. The user needs to understand how to interface with a toaster. But the user also needs to understand how the toaster is going to interface with the bread. Now, it's not just understanding that there's an interface, we need to dive deeper into each interface point, each relational joint, to understand what is needed to be handled, what information needs to be known and handled to be able to operate it successfully. In this case, the user and the toaster directly, the user needs to understand how it operates, buttons and levers, how they function, how to properly handle the toaster, how to plug it for power, and the correct orientation. Between the toaster and the bread, the user needs to understand that there's a platform that will lower the bread inside the toaster, in which metal coils will heat up and toast the bread. The user needs to understand that he or she is waiting for an auditory signal that will then eject the bread, telling the user the task and the goal are complete. And all of this requires a cognitive load from the user, not just to navigate through all of these pieces of information, but to handle them and juggle them and manage them while navigating through this relational pathway to successfully be able to make toast, achieve the goal. Now, a relational pathway diagram of making toast will look something like this, with two relational joints, the user toaster and the toaster bread. Now let's try applying this into the game world. The user needs to understand the interface with a controller, how to properly hold it, how to push the buttons, but also how the controller interacts with the avatar, how the controller maps to the avatar. I mean, do I press X and the avatar jumps, circle, I roll, but also the avatar to the digital world. The interactions between them. Can my avatar climb the wall? Can my avatar open up a chest? And also the digital world with the goal, its relations. Do I need to open the chest and there's going to be the coin? Do I need to destroy a boulder to be able to get my gold? So forth. Now the relational pathway diagram of navigating through a game level is going to look something like this, where the user has to understand the interface with a controller, but also the controller and the avatar and the environment and the goal. Now it is important to note that we have 4 relational joints in the game level relational pathway, which is more relational joints than when a player or user is navigating a user interface component even though it's in a game. For example, in the main menu, the player needs to understand how to interact with the controller, how to hold it, how to press its buttons. But instead of understanding how the controller interacts with the avatar, it needs to understand how it interacts with the UI, moving up and down the menu options, and then the UI to the goal. I press save and it will save the game. In turn, this relational pathway for the main menu or the UI component in the game has more relational joints than making toast. Now, an interesting concept to also note in all of this is the amount of relational joints that are present in any relational pathway, which I am coining as articulation. So, a relational pathway that has more relational joints in it is more articulated than one that has less relational joints in it. For example, the game level relational pathway is more articulated than making toast. So this is important to note because we can reasonably conclude that the more interface points, the more relational joints are needed to successfully navigate that relational pathway to achieve that goal, the user is going to necessitate different amounts of total cognition. And this is important because we as humans have a limited amount of working memory, of cognition that we can use at any given time. At the moment, psychologists have stated this to be 110 bits per second. Now, if we go over this and a task requires more cognitive load than what we can handle as humans, we experience a negative situation. And this brings forward the flow state concept, which was brought forth by Mihaly Csikszentmihalyi for the psychology field too in his work Flow, the Psychology of Optimal Experience. And we can present the concept as the optimal state of mind when performing a task. This is the holy grail every game maker is after, be it professional AAA or indie or just hobbyist. If you're making a game, you want people to play it, and people want to play a game if it's enjoyable. And what we're looking for is that perfect balance between challenge and skill, which brings forth that optimal experience. Let's dive deeper into the flow state concept so we can understand it better. So the flow state concept establishes that every task is performed between or in relation to a metric of challenge, difficulty, and skill level. So let's say that we are offered a task which our level of skill is higher than the challenge itself, which requires low cognition on our part to be able to perform this task, which in turn makes us feel bored. But let's go to the other extreme. if we encounter a challenge that is greater than our skill level at the moment, this in turn requires a higher cognitive load to be able to figure out and perform this challenge, which in turn creates anxiety in us. The flow concept states that the optimal experience, the optimal being and performance of a task is a balance between skill level and challenge, which is going to require just the right amount of cognition on the user's part to create an enjoyable experience. If we go over these cognitive limits of the user, we create specifically a disbalance of the flow state, of the flow balance, and we're particularly and specifically pushing the experience towards anxiety. So how can we apply this for game design? This is a relational pathway for navigating a game level. What we're going to do for purposes of illustrating the concept further is that we are going to theoretically state that a person, a user, has 5 units of cognition. We're going to represent these units with circles, and each circle is valued at 1. Now, we have to remember that if we go over this cognitive limit, we are going to create a bad experience for the user. So what we're looking for is to have the user use the right amount of cognition, balance it in the right way to create an enjoyable experience. So there's another important concept that we need to understand also, and it's that there's a hierarchical progression in every relational pathway that needs to be followed in a specific order to be able to successfully navigate through all the relational joints to be able to successfully get to the goal. For example, what I mean by this is the player needs to understand first how to interact with the controller, how to hold it, before understanding how the avatar interacts with the environment. Theoretically, from a third person point of view, you could do this, but if you are personally navigating this relational pathway, you need to go in a specific order. So that means that we need to go from 1 to 2 and so forth. So let's say that we have a game, and the relational pathway for the game is the one that we have in front of us. The user needs to first understand how to interface with a controller. That means that cognition needs to be allocated to this specific relational joint. But the player also needs to understand how the controller maps to the avatar. Another unit has to be applied to this. But our game is featuring a really cool interaction between the controller and the avatar, and it's new. So that will require more cognition allocation to this point for the player to be able to successfully operate and be able to move past it. So then we're moving to the avatar environment, which needs another unit. But someone in our game design group had a really cool idea for this really cool feature between the avatar and the environment. So we're needing to allocate another cognitive unit to it. And now that we get to the environment goal relational joint that is needed to be able to acquire the goal, we already ran out of cognitive units. Now we're asking the user, the player, to go over their cognitive capabilities, which ends up creating a bad experience. So how can we apply this in a more practical manner? So we understand that every single relational joint in this relational pathway needs to have cognition allocated to it to be able to successfully navigate through it. But let's say that we are introducing a new control design or a new way that the player can interact with the controllers and the avatar. So that would mean that we need to allocate whatever cognition we can still allocate in this relational pathway for these specific relational joints that will still not go over the cognitive capabilities of the user. So that means that we need to be extra careful on how we treat the rest of the relational pathway. That means that the avatar and environment interactions and the environment goal interactions need to be addressed with a simpler design. But let's say, in another example, we are introducing a completely new genre or a fundamental change in a mechanic in a game. So this would require that we allocate that cognitive load into different areas. In this case, it would be the avatar environment or the environment goal interactions, which means that now the user controller and the controller avatar interface points or relational joints need to be addressed with a simpler design. And with these concepts, with a relational joint, the relational pathway, and how cognition works in humans with affordances and signifiers, I hope this knowledge helps you to understand better how users interact with objects, but also how interacting with objects or environments is more complicated than what it seems at first. I hope you understand better the nuances that need to go into it and the great opportunity that we as designers, via this knowledge, these concepts, we have to better understand the user experience to better design it. And with this, I would like to remind you that we, as game makers, are, in some type or form, some scale, creating worlds for players to go in them, to experience them, to have a good time. But this also means that we're creating all the informational infrastructure, all the design decisions that entail the mechanics, that entail character designs, that entail their physics of the world, the combat system, the inventories, and at the end, everything. We need to design everything. And this puts a great burden on us as designers, but also create great opportunities. And we need to understand that we're not just creating the affordances of this game world, but we're also creating the signifiers of it. How the player is going to communicate with the game world is also our responsibility. How they're going to communicate and understand it. And we need to be conscious of this to address them, design them, understand the potential they have and how they impact the experience of the user. Understanding also how cognitive load is used and how we can better manage it through these signifiers and affordances, and understanding how cognition is used by the player, how we as designers, using affordances and signifiers, require players to use this very limited, precious resource of cognition that they use to be able to navigate the experience of the world in the game that we are coming up with, that we want them to enjoy, is also very important, as it affects the overall outcome of the experience of that person in our game. So we're not only the architects of a game world, we're also the ushers of the user's cognition. So I hope that with these new conceptual tools, the relational pathways, and this new perspective on what is cognition, how it is used, and how we need to manage it for the user. So with this, I hope that with this new knowledge and tools, you are better equipped to understand and visualize the nuances of designing experience, to better craft, allocate the cognitive requirements within the user's limits and optimize the particular experience that you want to bring forward to this user, the experience you as the game maker want it to be. And I hope this will help you create wonderful worlds to experience the flow state. Thank you. And if you guys want to know more about me or contact me, you can go to my portfolio page on simonhoffiz.com.
All right, Simon, lots of good praise in chat, lots of applause, lots of good information. Thank you very much. If you have questions in chat, please type them on in, and I'll start off with a few of mine. Ex-Cosmic Artist says, really informative and easy to digest info. J Ching Games says, thanks for the presentation. Home Team Game Dev says, clap, 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 clap. And Ex-Cosmic Artist adds a whole bunch more claps than that. So a lot of great info in there, especially in regards to signifiers, affordances, etc. There's also something called a theory of place, which I think ties pretty well into this. So just like we have an expectation of what a door does, though I got to admit, in games, I really want to be able to bang the door into my enemies' heads a few times. We have an expectation of what barrels do in the real world. They obviously explode. We also have an idea of what a place does. So if we think of a church, we know what we think it looks like, what happens there, what objects are there. Same with a school, which is part of why games have a lot of fun in turning those on their head. Suddenly you're shooting up churches, running around schools, going crazy, and so forth. What do you think of it when games take signifiers and affordances, use them in ways that we're not expecting? Go ahead.
So that's actually another idea that I've been working on, and it's like, so we see an environment, right? Like from an architectural standpoint, let's say we're in a cafe. So as an architect or someone that's actually in the physical world navigating that space, you associate that with sitting down with a cup of coffee, with a friend, with a book, right? But in a game, it all depends through the lens of the game. For example, if we're doing, I don't know, Watch Dogs, which is kind of like parkour-y, stealth, stealing information from people, that place is not so much a cafe as an environment to acquire a goal. It could be that cafe, the seating, the tables are not. You don't see them as that. You start perceiving them more as obstacles to traverse with your parkour abilities. So yeah, it depends on where the person is coming from.
Excellent, excellent. Home Team Game Dev says, reminded me of things we spent weeks reading about and talking about in grad school. This talk was way more practical and efficient coverage of it. Ex-Cosmic Arts X says, a bit off topic, but do you recommend getting a master's for a specific aspect of game design, such as sound engineering, 3D level design, texture artists, etc.?
So I am don't take my advice as with a lot of weight, because I myself I'm new to the industry. I've been roaming around it for a couple of years. I've been approaching it as a hobbyist. I'm trying to get more serious into it. Hence the trying to the public speaking, getting out with design talks and the design ideas, because I think I can add something to it. But my experience has been that this is a field where your portfolio matters more than your degree, which I don't know if it might be just a phenomena when comparing it to the other kinds of industry, or that it is, since this is a craft industry, you really need to show what you have learned through your experience. And theory is good. I mean, I'm a lover of everything, theoretical, but I've also learned that you need to apply it. And I think you can get as good as a job, or maybe even better, if you start working on your portfolio, actually go through YouTube, actually, buy yourself some books and actually build up a portfolio in 4 years, rather than go get a degree, that will take you 4 years, do half the work, or end up with half the portfolio that you're going to end up if you're just, focusing on 4 years of work on your portfolio. You're probably going to end up getting a better job, or taking that person's seat with your portfolio than the person that spent the 4 years in a degree.
Yeah, and J Chin Games says, totally true. Your work matters more than the degree. X Cosmic Arts X, I will also add that if you look at game job ads on the Gamma Sutra site, you will almost always see must have 4-year degree. Requests for masters are very rare and usually only for programmer positions. However, if your goal is to teach, then that master's suddenly becomes a lot more valuable. And there are very few people right now who have both the industry skill and the degrees that make them great teachers in this space. So more of those are going to be invaluable. So MFAs and so forth are going to be very useful tools if you want to both make games and teach about making games. Let's talk about games that you think do this well. One thing I loved in your presentation was how you applied this to user interface design. And it's very true. Being able to handle the controls is a major part of what turns us on or turns us off in a game, and how well the game lets us do that is important. The classic example is always Tetris. Controls are simple. You figure them out quickly, but then it starts speeding it up, and now you have to really have mastered the controls. What are some other games you think that do that well? What take this idea and apply it well to the user interface?
So I would. Sorry.
And you can use your own as examples.
Well, a personal point of frustration when I'm going through itch.io or just playing someone else's game, it's the controllers, because people as game devs, they inherently and intimately know what they're making, but someone outside, even though they might be a game developer also, does not know that you need to, that you is actually, to get into the main menu, but then you have these other 15 buttons that you need to know how to operate to be able to efficiently and be able to navigate the world. And that is one of my pet peeves and greatest burdens every time I go looking for, other hobbyist games, is that they don't understand that they need to make the controllers as simple as possible, because if I'm going to spend 15 times, or what has happened is I'm only going to spend 15 times on any given game on itch.io, right? And when I need to spend 10 minutes out of those 15 minutes just trying to figure out how the controllers work while being killed, that just creates a negative experience.
All right. We're going to have time for one more question. I'd like to have gone longer with this, but I've been streaming all day, and I told my family I'd be done by 8:30. So you have time to type your question into chat. My last question, do you have more sources that people can study on this? More readings, books, videos? What should people look at next if they're interested in more on these topics?
Nothing off of my head right now. I do have all of those books are game design books. So I definitely have a library that I can share, and this is a accumulation of a whole lot of pieces of ideas that are spread out through books and some of mine. But yeah, I can definitely, if someone's interested, I could definitely share a book list.
All right, and I'll go ahead and field the last question since we're not seeing more here. In the current game you're working on, can you give us an example of how you're implementing some of these theories?
Yeah, so one of the major points, okay, so this game is being done in home game dev team, collaboration online team that I'm part. I mean, all of those games that I've been working as a hobbyist, like looking into the intro for this industry, has been there. And this is my first time leading a game. And one of the major design points was I want super simple controls. So in this case, it's a vertical space shooter. I'm starting to learn how to program, so I wanted to go with something super simple. So you basically only have the spacebar and the arrow keys, and that's it. And everything else that happens, like the level ups of the ammo or the weapons, and everything can only use those 5 controllers or those buttons.
Excellent. All right, great stuff. Okay, thank you, Simon. Everybody, Hiccup Interactive, Karen Williams, who was one of our SimFest speakers on Saturday, is currently streaming on her channel. So I'm going to host them. That should be the equivalent of a raid. So whatever you type in the GGDA chat, she should C. So as soon as you see that pop up, go ahead and type in hi hiccup. So let's see if I can make that happen. Here we go.